Welcome to Brain Vision.
The velocity selector eliminates all ions not having the desired velocity. Then the magnetic field bends the ions in a circular arc. Now, in a velocity selector, the magnitude of electric field is equal to the magnitude of magnetic field, and the direction are opposite for both the forces. So the magnitude of the electric force is equal to the magnitude of the magnetic force, and so this gives q times E is equal to q times velocity times b. There is no sine phi because velocity and magnetic field are perpendicular. So this gives the electric field to be V times the magnetic field. So from here we can calculate the velocity, which is equal to E over B, and this is found to be, so let's calculate that. So for this case, I forgot to write that. So this is for part B. So for this case, the magnetic field is 0.0315 Tesla. So we use that in this equation and we get the velocity to be 4.92 times 10 to the power minus 3 meter per second. Now, for motion in a circular arc, the particle enters a magnetic field of magnitude BB. So this is part A for this part. Now, for this case, the magnetic field bends the ions in a circular arc. So, since a particle is moving inside a circle, uh, the magnetic force, should be equal to the centripetal force, which is given by mv square over r. And the value of the magnitude of the force is equal to q times v times b. And from here we can find the mass, which will be equal to R times Q times B over B, where is a positive ion of charge of the electron. So we calculate this and we find the mass to be, so the value of R is 0.175 meter, and we use that in this equation and we find the value of mass to be 9.96 times 10 to the power minus 26 kgs. So ions with larger ratio of m over the magnitude of q, or the charge, will move in a path of bigger r, where r is the radius of the circle.